James Webb has captured something strange in our solar system, and no one in the mainstream media is saying anything about it. The data from the examination does not match known comets, asteroids, or debris drifting in from deep space. Behind closed doors, researchers are re-examining assumptions they thought were settled, because if the readings are correct, then this object does not belong to any category we currently understand. The object that refused to behave like a comet. It gave us a sense of where we came from and also where we are going. James Webb has captured something strange in our solar system, and no one in the mainstream media is saying anything about it. That sentence did not come from a headline or a press release. Rather, it came from internal chatter among astronomers who realized that one particular object was refusing to follow the rules they relied on to understand space. All along, 3IATLAS has been officially classified as an interstellar visitor. That label alone meant it came from outside our solar system, carrying material older than Earth itself. At first, scientists expected a familiar story. Interstellar objects are rare, but they usually behave like comets once they approach the sun. Heat increases, ice vaporizes, and a faint cloud forms around the nucleus. This process is predictable, slow, and well understood. But with 3IATLAS, that expectation collapsed almost immediately. As the object moved inward, telescopes did not see the usual pale cloud. Instead, James Webb detected a thick green halo surrounding the object. This is a worldwide telescope all these countries are willing to make to reach the edge of the universe. The color came from diatomic carbon, which is a fragile molecule that normally appears briefly before breaking apart. In known comets, it fades quickly and never dominates the coma. Here, it did not fade but intensified. It wrapped the object completely, as if being sustained rather than released. Scientists flagged the anomaly but tried to remain calm because chemistry in space can be strange. But then something appeared that could not be brushed aside so easily. A structure formed that pointed directly toward the sun. Comet tails always point away from the sun. This is not a theory or an assumption, but basic physics. Solar radiation pushes dust and gas outward, creating a tail that streams behind the object like smoke in the wind. Yet 3IATLAS did the opposite. Its so-called anti-tail pointed inward toward the source of radiation that should have been pushing it away. Public explanations leaned on camera angles and perspective effects, but internally those explanations did not hold up. The geometry was wrong, yet the structure persisted across observations. Step through a situation where an asteroid is discovered so many years ahead of time. Here are the possibilities of what could happen next. It did not behave like an illusion, but behaved like a maintained feature. James Webb's infrared data made the situation more uncomfortable. The green halo was not random or smooth, rather appearing layered with bands that brightened and dimmed in sequence. But natural outgassing does not happen in organized phases. Comets leak and they do not pulse. What Webb saw suggested timing, not chaos. Then came the observation no one expected to see at all. X-ray telescopes detected emissions stretching hundreds of thousands of kilometers away from the object. While comets can produce X-rays through solar-wind interactions, these emissions were unusually intense and stable. X-rays at that scale usually require violent interactions or powerful energy sources, and cold interstellar debris drifting through space should not produce them. Yet the emissions were there, and they did not flicker or vanish. The stability of those X-rays was what unsettled researchers the most. Random interactions spike and fade, yet these emissions held steady. It looks so harmless, a few pixels. You realize what it means to actually see another planet moving around the sun. It's incredible, implying an ongoing process rather than a single event. That was when the speculation began, quietly. Some experts insisted that this was some form of exotic chemistry. Some said it was caused by unknown surface reactions. Models were proposed and adjusted, but they ended up being quietly set aside when they failed to explain everything at once. By this stage, the language used in internal discussions reportedly changed. Scientists stopped asking what type of comet 3IATLAS was. Instead, they began asking whether it belonged in that category at all. Still, every defining behavior used to classify comets, asteroids, or debris seemed to break down under closer inspection. Nothing about the object was dramatic in the way movies portray danger, as there were no explosions, no sudden movements, or any obvious threat. Instead, there was something far more unsettling. It was a calm, steady violation of expectation unfolding slowly, data point by data point. 3IATLAS was not acting broken, it was acting consistent, and that consistency is what made it impossible to ignore. And as researchers moved past appearance and began examining the object's chemical makeup, the idea that this was just an unusual comet became even harder to defend.
A chemical profile that should not exist. Of the near-Earth asteroid, we should be able to compare and tell what the near asteroid is made of. Once the first structural anomalies were logged, attention shifted to something far more intimate, what the object was actually made of. This was supposed to be the part that grounded the discussion. Chemistry does not lie, and spectroscopy in particular is considered brutally honest. Light passes through gas, fingerprints appear, and arguments usually end there. The surface gets warmed up and the ice turns into vapor, gas. That was the expectation when researchers turned their instruments toward 3IATLAS. No one expected the readings to look like this. The spectroscopic instruments revealed something that made a few of the technicians stop mid-log. It was methanol and hydrogen cyanide, both at levels far higher than anything ever recorded from a comet passing near Earth. Scientists had seen comets release volatile compounds before, but these precise and consistent ratios did not match any natural model. The silence in the room was almost tangible. The flow of molecules didn't pulse in the chaotic, unpredictable manner one would expect from heating ice. It was continuous, almost controlled, as if the object contained internal reservoirs that were releasing chemicals on some unseen schedule. Heat alone could not explain it. Pressure gradients, sublimation, outgassing, and everything in standard comet theory fell apart under the data. The scientists tried to rationalize it quietly, but no matter how many models were run, none fit. Each failed attempt only deepened the unease. And then there was what wasn't there: water vapor, the lifeblood of every comet. We thought comets only released light gases. Water vapor accounted for less than 1% of the emissions. It was not 10% or 5%, but less than 1%. For an object that seemed so active, that level of water was impossible under conventional physics. Researchers explored water activity on the comet and provided the first clear evidence that it was shedding water. Comets are ice-rich as they melt, release, and jet. But here, something fundamental was missing. The usual engines that drive behavior in icy bodies, which are the very physics scientists trusted, had been silently removed from the equation. The object was active, yet lacked the primary mechanism to explain that activity. Some discussions reportedly took a darker turn. In whispers behind closed doors, researchers asked whether the chemistry was merely surviving the journey across interstellar space, or whether it was being actively preserved. Perhaps, one suggested, the object had traveled for millions of years, and yet these molecules remained intact, untouched by radiation and collisions, somehow maintained against the odds. Another posited that it wasn't just preserved, but could be producing them deliberately and systematically. No one said it aloud, but the tension made the room feel smaller. The object's very existence was beginning to read like a puzzle that shouldn't have an answer. Even casual observers, brought into the control room for a moment, reported unease. There was something inherently wrong about an object so consistent in behavior, so precise in its chemical output, and so utterly incompatible with expectation. The mood shifted quietly from curiosity to discomfort. Scientists began questioning assumptions they had relied on for decades. Questions like, what is this made of and where did it come from, now felt inadequate. They started asking questions that had no answer. Why does it exist this way? And more disturbingly, was it ever meant to exist at all? By the time the data logs were compiled for review, one thing was clear. 3IATLAS was not just unusual, but impossible. And the more the scientists examined it, the more impossible it became. Each measurement, each spectral line, each persistent emission pulled them deeper into a truth they weren't supposed to confront. Perhaps this was not a natural visitor, that the rules the universe had always followed, at least in their models, might not apply here. And if the chemistry was deliberate, and if the object itself was controlling the release of these compounds, then nothing about its passage could be taken at face value. The quiet realization settled over the room, like frost. They were no longer observing a comet. They were watching something that had been designed, or had designed itself to behave this way. And the implications of that thought were enough to make even the most rational researcher pause.
As the chemical profile defied explanation, the object's movement path through space began to compound the mystery, suggesting intelligence, or at least deliberate control beyond human understanding.
The trajectory that looked calculated, not natural, tracking 3I-ATLAS as it moved inward was like watching a slow-motion heist unfold. The first movement anomaly appeared in the raw orbital data when the object began accelerating in ways that should have been impossible. Gravity alone could not account for its path. And yet when scientists tried to attribute the shift to outgassing, the math didn't fit. The plume of gas around it is mostly carbon dioxide, 95% by mass based on the Webb Telescope data. Jets of material should have pushed it in line with their visible emissions, but they didn't. The direction of motion, the speed, and the consistency did not obey the rules. Rather, it looked like the comet knew where it wanted to go. The second anomaly was harder to ignore. 3I-ATLAS was following a retrograde trajectory that skimmed the orbital plane of Venus, Earth, and Mars with chilling precision. Each pass was nearly perfect and aligned as if the object had been plotted on a map. And we have a better idea of the orbit of this object. This might be a brand new, unknown, potentially hazardous asteroid. Rather than left to chance, astronomers ran the numbers, and they were shocked to see that the odds of a natural interstellar object threading that needle were astronomically low. One orbital dynamicist, normally cautious with words, called it engineered-looking in a leaked internal memo. The phrase was not meant for press release because it wasn't something any scientist could say lightly. The object's movement was the kind of alignment that didn't just happen. Observers noticed that 3I-ATLAS avoided the kind of chaotic encounters that typically scatter cometary paths. Its timing minimized gravitational disruptions while maximizing observational windows from Earth-based and space-based instruments. The path was not approximate but looked refined, as if subtle nudges, too small to detect, kept it stable and visible. Every calculation and simulation suggested intention behind the movement, even if no one could explain how a cold rock from another star could intend anything. The tension in the room rose as the object approached Jupiter. The planet's massive gravity should have torn the trajectory into chaos, scattering the object like debris in a storm. This is the first time something like that is observed, where there is a glow ahead of the object towards the sun. Instead, 3I-ATLAS skimmed the planet's hill radius with uncanny accuracy. Even though this was the very region spacecraft engineers use for gravity assist maneuvers, any natural object passing through this zone faces risk, and a tiny deviation could alter the path dramatically. Yet this object emerged cleaner than it entered, with its trajectory even more stable than before. Data streams, JWST, didn't show random deflection, but control. It was as if the object had leveraged Jupiter's influence deliberately, borrowing energy without being disturbed. By this point, the scientists' conversations in observatories began to shift tone. The question was now, could it be navigating? Some researchers hesitated to say it aloud, because the idea of an interstellar visitor making decisions and charting its own course across millions of kilometers of empty space sounded absurd. The motion of 3I-ATLAS was perfectly aligned with that of Venus, and that is something that cannot be explained just by observing or imaging it. But the evidence left little room for natural explanations. Each pass and each adjustment was consistent with a single, unsettling implication that this was not a visitor drifting randomly, it was a traveler with intent, moving through the solar system in a way that demanded recognition. And yet there was no explosion, no visible engine, no smoke or flame, just deliberate, impossible-looking movement. It left the scientists feeling exposed, as though they were staring at something that had been watching them, planning its path while they merely tracked it. The more they examined, the harder it became to defend coincidence. 3I-ATLAS was threading with precision, and the universe they thought they understood suddenly felt suspiciously conscious. 3I-ATLAS does give scientists a rare chance to study something from beyond our solar system, and if its motion suggested deliberate control, the object's physical structure only amplified the unease, revealing features that defied every expectation of a natural interstellar object.